means working with different technologies, machines, sensors, controllers, and different software applications. And that results of having many data that gets generated. So finding a method to monitor all the information in real time is crucial. SCADA is a powerful control system that is designed to collect, analyze, and visualize data from. Before you start this course, you should have a general idea about the system architecture in industrial automation, as well as you're a little bit familiar with how ladder logic programming works, using the basic instructions, like how to use input and output instructions and timer instruction. I will cover everything needed for this course. However, to get you prepared, I recommend the following. First, to get familiar with the software that I'm going to use for the SCADA project in Chapter 4, check the following course: Simulation Software Factory I/O with Connected Components Workbench. The course covers an introduction to the two software as well as working on 4 projects. In this SCADA course, I'll be using the project in Chapter 5, Filling a Water Tank. Exercise files are divided by chapters, as you can see here, similar to the order of the chapters in this course. Now for this course, I have exercise files for Chapter 2 and Chapter 4. In Chapter 2, I have file for Connected Components Workbench Software, and for Chapter 4, I have files for Connected Components Workbench Software, Factory I/O, and Ignition Designer Software. Now I'm going to show you how to open the files in their software. For Connected Components Workbench Software, go to File and then choose Open, and then go to the Exercise Files folder. And let's say, for example, I want to open the file in Chapter 2. So click on that. Then click on Connected Components Workbench Software. And this is the file name. And then choose this file and click Open. Now to open the file for Factory I/O software, go to the exercise files and then choose the Factory I/O folder and then copy this file. And then go to the Factory I/O software, and it's usually in the documents. Then go to My Scenes and then here paste that file. Then, in the Factory I/O software, click on Scenes, choose My Scenes, and then you'll see the file here. Select it, and it will open in the Factory I/O software. And finally, for the Ignition Designer software, go to Ignition Designer, and then choose Import Project. Then from the Exercise Files folder, choose Chapter 4, then Ignition Designer Software, select the project, and click Open. Here you would need to give it a name, so I'll leave the default name as it is, and click Import Project. Now for Ignition Software file, you will probably won't need this until the end of Chapter 4, as I will go through the steps of how to create a project in Ignition Designer. I have also explained how to export and import Ignition Designer project file in Chapter 4. The basic SCADA architecture includes, first, a controller. An example is Programmable Logic Controller, or PLC. Then, a factory field device, like sensor. An example is photoelectric sensor or proximity sensor. And finally, a SCADA software to collect data. Sometimes, instead of PLCs, a remote terminal unit or RTU is used. An RTU is a microprocessor-based device that monitors and controls field devices. RTUs usually used in remote locations, like pump stations or wastewater treatment locations. Another example of factory devices are variable frequency drive, or VFD, and a pump. Also, human machine interface, or HMI. These devices gather information and send them to the computers with SCADA software. The SCADA architecture can be a big system, including multiple processes, many devices, sensors, and equipment within the factory. The SCADA software processes, distributes, and displays the data, helping operators to analyze the data and make decisions. SCADA systems include two main parts: software and hardware elements. Hardware including factory devices and machines, field sensors, controllers like PLCs, DCS, human-machine interfaces, communication network system equipment, SCADA host computers and monitors, master terminal units or MTU, and remote terminal unit or RTU. Software includes any software used to collect, process, distribute, and display data, like the main SCADA software, any networking software used, HMI designer software, and even the software used for configuring PLCs and sensors. Here's an example of a SCADA system. This system consists of devices and software from different manufacturers. This system has two processes. Process 1 includes a conveyor belt with two sensors, a laser distance sensor from Wingler, and a proximity capacitive sensor from Omron. And they are connected to Allen Bradley Micro 820 PLC. Process 2 includes a level sensor for measuring a liquid in a tank, similar to processes in food and beverage industries. An example of a level sensor is from Endress-Hauser that is connected to Schneider Electric Modicon PLC. And each software in this SCADA system is also from different vendors. The PLC programming software for both PLCs are Connected Components Workbench from Rockwell Automation and EcoStructure Machine Expert from Schneider Electric. An example of OPC software is Kepware Server. I will cover more information about OPC in details in the next chapter. And Ignition software is the SCADA software. This is the software I'm going to use in this course. So, SCADA system makes it possible to share and collect data using all these different devices and software and make them accessible using one interface. SCADA software helps in connecting to field devices, controllers, and equipment to facilitate the process of having real-time data monitoring. But again, SCADA is more than just a software. SCADA is a system. It is a collection of both software and hardware components. In this video, I will give you an overview of the different software used for SCADA systems. I'm not doing any comparison between them. My intention is to introduce you to some of the software available in no particular order. And keep in mind, in general, each manufacturer in industrial automation has a SCADA system for their products. Ignition software is by Inductive Automation. It is an industrial automation software platform that has a user interface that can be designed for SCADA system to show process data in real time. Ignition software is the software I'm going to use in this course. I'm going to explore it in details in Chapter 3 as well as the practical example in Chapter 4. Many software provided by Rockwell Automation, like for example FactoryTalk software, Foxborough SCADA software by Schneider Electric, ThingWorx software by PTC, TATSoft Factory Studio SCADA software by TATSoft, Aviva Edge SCADA software by Aviva, Simatic SCADA system software by Siemens, iFix SCADA software by General Electric Digital, and Litmus Edge SCADA software by Litmus. The SCADA project I'm going to cover in details in Chapter 4. You see on the screen I have a field application scenario, filling a water tank. Everything is connected to a PLC, and I use a PLC ladder logic programming software to program the process. Then using an OPC to transfer the data to a SCADA software for monitoring. In the next two chapters, Chapter 2 and Chapter 3, I'm going to introduce you to OPC server and client and a SCADA software, Ignition software, covering Ignition Gateway and Designer. In order to use both software in the project covered in Chapter 4. The final project includes the software you see on the screen: Factory I/O software, Connected Components Workbench software, OPC Cogent Data Hub software, and Ignition software, Platform Communications. It is the interoperability standard for the industrial automation and manufacturing. OPC is a platform that ensures the seamless flow of information among devices from multiple vendors. An example you see on the screen showing two devices, one from Siemens and one from ABB. The OPC Foundation is responsible for the development and maintenance of this standard. Here is an example. If I have data coming from sensors connected to a PLC to a local computer within the factory floor, and I want to display the data in a display monitor in the control room, in this case, I can use an OPC software to enable and facilitate the exchange of data between the two devices. So, OPC stands for Open Productivity and Connectivity in Industrial Automation. It is a powerful tool that is used in the applications where they need to access data from any data source and then present them in any other devices. OPC is implemented in server-client pairs. In any OPC connection, there is a relationship between two computer applications. One application acts as the server providing data, and the other one acts as a client using data. Server-client pair, sometimes referred to as parent-child pair, where server is the parent, client is the child, and in some documentation also referred to as primary and secondary. Different naming conventions for the same concept. OPC server and client can be within the same computer locally or between two computers remotely using a network or internet. An OPC client is basically any device, software, or application that uses and receives data, either to collect, analyze, or to send them somewhere else. In the example you see on the screen, the OPC client is an HMI to show the data coming from two field devices, Siemens and ABB sensors. An OPC server is a software program to provide data. The software has been written to one of the OPC specifications that converts the hardware communication protocol and data coming from devices or PLCs into the OPC protocol. An OPC server will respond to requests and provide data to one or more OPC clients. In the example you see on the screen, two devices from two different manufacturers, Siemens and ABB. Each has its own OPC server. The OPC server is to facilitate the data exchange between the sensors and the OPC client. Now, there are a number of open source initiatives for OPC servers already available to be used with different manufacturers. So you can either use an OPC server of one particular manufacturer or an open source one. For OPC connection, in the parent-child model, the parent application controls one or more other applications, the children. Once the parent-child relationship is established, the direction of control is always from the parent to the child, from server to client, which means an OPC server will only transfer data to and from a data source if an OPC client commands to it. In the example you see, the data source is a PLC collecting data from field devices. The OPC server converts the data coming from hardware devices into the OPC protocol. The OPC client software, on the other hand, is any program that receives the data and connected to a hardware, such as an HMI. The OPC client uses the OPC server to get data from or send commands to the hardware. Here are some examples of different OPC servers and clients. One of the main reasons that OPC is a widely accepted industrial communication standard is its ability to connect to different controllers from different vendors and to enable the communication between them. In the example you see on the screen, controllers from Siemens, Allen Bradley, and ABB each has its own OPC server. So, if a field device, for example a sensor, is connected to one or multiple controllers, the data is transferred from the sensor to the controller and then using an OPC server to be sent to an OPC client, where all data from different vendors are accessible using one place. Now, the data collected from the different vendors can be then used for different applications, examples like HMI, SCADA software, or stored in database. And another great advantage is using the OPC protocol to transfer data over a network and overcoming the security problems. The value of OPC is that it is an open standard, which means any OPC client can interface with and request data from any OPC server regardless of the vendor. So the hardware manufacturers need to only provide a single OPC server for their devices to communicate with any OPC client. There are two types of OPC, OPC-DA and OPC-UA. OPC-DA is the original version of OPC specification. The OPC-DA specifications are based on Microsoft Windows technology using the COM and DCOM for the exchange of data between software components. There are three types within OPC-DA. OPC Data Access, or OPC-DA, OPC Alarms and Events, or OPC-AE, and OPC Historical Data Access, or OPC-HDA. The OPC-DA specifications provide a separate definition for each one. You can read more about OPC-DA in here. The latest generation of OPC is known as OPC Unified Architecture, or OPC-UA. OPC-UA was designed to enhance and surpass the capabilities of the OPC-DA specifications. OPC Unified Architecture was released in 2008. It is an independent, service-oriented platform that integrates all the functionalities of the OPC-DA specifications into one framework. It is a cross-platform protocol, and that is why it does not depend on any particular operating system or programming languages, and hence the name Unified. The architecture of OPC-UA is service-oriented, and it also functions on different hardware platforms. For example, the traditional PC hardware, cloud-based servers, PLCs, microcontrollers, etc. And the security provided by OPC-UA is robust. You can read more about OPC-UA in here. So now, depending on each application or process requirement, the choice of OPC-DA or OPC-UA is determined and also depends on what the manufacturer provides. You need to check what is the OPC server for each device you are working with. In general, an OPC-DA server connects to OPC-DA client, and the same thing for OPC-UA. There are differences between the two types, but the main one is OPC-DA is completely operating system dependent on Windows platform, where OPC-UA is independent of the operating system. Also, OPC-DA communication medium is COM and DCOM, where OPC-UA is about TCP and IP. There are many open source OPC software that are available. I'm going to introduce you to a couple of them in this video. Please note that usually manufacturers provide OPC server for their products and applications. Cogent Data Hub OPC is a software provided by Skynet company. The OPC software application is used for industrial automation. You can download the software by clicking on Download here. You need to fill this form and a link will be sent to the email provided. This is how the software looks. I will give you a tour of the software in the next video. This is the software I'll be using in Chapter 4 for our SCADA project. CAP server from Kepware is one of the common OPC servers used in industrial automation field. You can download a free demo by clicking on here. You also need to fill in the form here. There is some limitation for the demo-free version, but it is a great tool for learning and practicing. You can use this manual if you want to read more about Kepware server. Top server is also one of the common OPC servers used, and you can download it by clicking on download here. There is also a trial version, and the software layout looks pretty similar to Kepware server. The Software Toolbox website also provides links to download a couple of the OPC servers. Finally, you can find OPC servers from Matricon website as well. Now, once you download and install Cogent Data Hub OPC, you can double-click on the icon here. Then you will see this message that the software can run for 1 hour. You can always relaunch it again if needed. I'm going to click OK. Then I'm going to go here, right-click on the Cogent Data Hub icon, and then select Cogent Data Hub. The main page includes the general settings. I usually leave the default settings for any demo projects. On the left-hand side, you see all the different options for OPC. For example, OPC UA, OPC DA, OPC A and E, and each is used for different application. The OPC UA section has two main functions. If you want the Cogent Data Hub to act as OPC UA client to many OPC servers, then you need to check the box here. And if you want to add details of the OPC UA server, you can click on Add here. And if you want the Cogent Data Hub to act as OPC UA server, here are the port settings if you need to access them. I usually leave these same settings unless I need to change a particular one for a certain application. The same thing applies for OPC DA section. Cogent Data Hub can act both as an OPC client and OPC server. And if you want to add an OPC server, you need to click on Add here and fill in the details of the OPC server. For example, here is the drop-down menu of the different OPC servers available on this computer. So once you add the OPC server, you click OK. I'm going to click Cancel for now. But I have one that I've added from previous project. So once you add it, you click on Apply here. And then if you want to see the data, you click on View Data. And then you can expand it here to see the tags. Currently, you don't see any tags because I don't have the server running. But I'll go through this again in the demo of this chapter, as well as the SCADA project in Chapter 4. One of the great features of Cogent Data Hub is that it can act as both an OPC server and OPC client at the same time. This means it can read from multiple OPC servers while acting as a client, and make the data available to any number of OPC client programs while acting as a server. This makes Cogent Data Hub software a link to facilitate the connection between OPC UA and OPC DA. You can connect OPC DA server to OPC DA or OPC UA clients, or you can connect OPC UA server to OPC DA or OPC UA clients. Cogent Data Hub also demonstrates different scenarios for OPC connections in a simple way, like tunnel or mirror and bridging. To connect OPC client to an OPC server over a network, this is called OPC tunneling. So for Cogent Data Hub, you can click on Add Master, and here you can specify the primary host, the secondary host, and the different ports needed for the server. Now, if you want to connect an OPC server to another OPC server to share data, this is known as OPC bridging. In some cases, the controller has its own OPC server that can be used as an OPC server to be connected to any OPC client. There are many other options within Cogent Data Hub you can explore, like for example, Web View to create an HMI, Web Server, MQTT, etc. But for this course, I'll be using OPC DA and OPC UA sections. You can check the Cogent Data Hub website where you can find more information about the latest update. You have the option of a full screen documentation, or you can download a PDF version. Here is an example of transferring data from a PLC through an OPC server and then display them in an OPC client. I'm going to use a simulator PLC from Connected Components Workbench software. When you download the software, it comes with a Rockwell OPC DA server that we can access using any compatible OPC clients. For the OPC client side, I'm going to use Cogent Data Hub to receive and display the data. I have provided you with this file from Connected Components Workbench software. You can find it in Chapter 2 folder. This file includes one running PLC program that when I click on this input address, this output address is activated. The OPC server is Rockwell IX LCIP Getaway OPC DA. The server runs on the local station, our computer, in the background, and I can see it in the OPC client directly. Since it is an OPC DA, I'm going to use Cogent Data Hub as OPC DA client. So the first step is to click on the simulator PLC, then have the power on. And I'm going to download this program into our PLC. So click on Connect here. So once the download is complete, I'm going to go to Cogent Data Hub software. Double-click on Cogent Data Hub icon. I'm going to click OK. Then go to the icon here on your right-hand side, right-click, then select Cogent Data Hub. Then go to OPC DA, and I'm going to add a new OPC server. Click on Add here. For the connection name, I'm going to name it Micro 850 Simulator PLC. I'll leave the computer name as a local host. And for the OPC server name, from the drop-down menu here, choose Rockwell Gateway OPCDA. Then for the data domain name, I'm going to give it Connected Components. Workbench software. I'll leave the other settings as they are, and then I'm going to click OK. And then I'll go to the Apply here and click on Apply. Notice the status is showing now running. Now, in order to see the data from the simulator PLC, click on View Data, and then click on the plus sign beside the Connected Components workbench, and then click on the plus sign beside the controller, Micro 850 and Micro 850. So what you see here are the data coming from Connected Components workbench software. So if I click on the directly represented variables, what you see here, the addresses are actually the addresses of the input and output of the simulator PLC. The same thing if I go back to Connected Components workbench software, and then I go to the controller variable. Here are the addresses that I'm currently seeing in the OPC client. So now I'm going to do a demo. So once I click on Run here, and then I click on this input address, according to our ladder logic program, this output is activated. And you can also see the change in the OPC client. So once I click on it again, it goes back to 0. Once I click on it, you can see the change is reflected in the OPC client. So this is the address for the input, and I'm going to scroll down here to show you the address of the output. So this is the address for the output, and the same, if I let go, it goes to 0. So now what you see here are the data in the OPC client coming from Connected Components workbench software. And I want to show you the data also from the controller variables within the software. So if I click on the input here, you see the input is changing to 1. And if I go back to Connect Components, the input is activated as well. So at this point, we have successfully connected the PLC simulator to our OPC client. Now, to find more information about the OPCDA server, the OPCDA is based on the DCOM configuration. So you can go to Run and then hit OK. Then type DCOM cnfg.exe. Then click OK. And then from this window, select Component Services, then choose Computers, My Computer. I'm going to expand the window a little bit, and then select DCOM configuration. Scroll down until you find Rockwell Automation OPCDA server. This is our OPCDA server, and then right-click on it and select Properties. This is where you can find more information about the OPC server, the application name, the application ID, the type, etc. I'm using the OPC client Cogent Data Hub on the same computer, and I didn't need to use all these information. But sometimes, if you are setting up the configuration on the client side over a network, you might need to have access to these information shown here. You can also find more information about the server by going to this file location path. Click on Program Files, then on Rockwell Automation, then select Connected Components Workbench Software, and choose Extension Folder. Scroll down until you find OPC Settings. So I'm going to right-click, and then I'm going to open it with a notepad. Notice here that the name of the OPC DA server matches what we found under the DCOM configuration. So now you can use any of the methods if you're looking for the application ID, the application name for this specific OPC DA server. Wonder, then what is the difference between SCADA and OPC? There's actual differences between SCADA and OPC, even though both have the essence of sharing and facilitating data exchange within industrial automation in a secure way. But OPC is part of a SCADA system to transfer data between two applications, where SCADA is actually the whole system, including the software and hardware. Now, there are SCADA software, like the one I'm going to use in this course in the next chapter. The software helps in connecting to field devices for monitoring, gathering, and processing real-time data. The software also helps in the supervision and control of the processes both locally and remotely. But SCADA is more than just a software. SCADA is a system. It is a collection of both software and hardware components. One of the greatest usages of OPC protocol is to transfer data over a network and overcoming the security problems. And this actually helps in the SCADA systems. OPC is an open standard, which means any OPC client can interface with and request data from any OPC server regardless of the vendor. And ignition software can generate dynamic reports using a report engine. Inductive automation provides different applications and solutions for many areas within industrial automation. But for this course, as the name indicates, a SCADA course, so I will only focus on the SCADA application using ignition software. Ignition software has two main parts that I'm going to work with in this course: Ignition Getaway Web Page and Ignition Designer. In general, the Getaway web page is for settings and configuration, and Ignition Designer is for designing the project. The basic flow is first open the Getaway web page for settings, then launch the designer to design the details of the HMI or SCADA project. Once you save the project, you can then access it using many local or remote applications or devices. Ignition is installed as server software and it is a web-based, so you can access Ignition Getaway using any web browser. Ignition is fully cross-platform software, meaning it can work with Windows, Mac, and Linux servers. Here's an example of how Ignition software fits in a SCADA project. Here I have data coming from sensors located on a conveyor belt, connected to a PLC, then using OPC server. In the example you see, I'm using Kapur server to send data to Ignition software. Ignition software has a built-in OPC UA server to enable us to connect to popular PLCs. And it can also connect to a third-party OPC DA or OPC UA servers, making it possible for us to connect to any PLC in the market. The software has the ability to connect to many connection points. It can connect to different PLCs through OPC servers, different SQL database, connect to any web service, different operating systems, MQTT, etc. It acts similar to a communication hub, where you can make different devices and applications speak to each other. To download Ignition software, go to Inductive Automation website, then select Download Ignition. The website detects your system. For example, here it's showing an installer file for Windows. So click on Download for Windows, and then you need to fill in information here, and then click Download. This will download the Ignition file into your computer. After downloading the file, double-click on the installer file here in order to run the installation. Click Yes here. Then I'm going to click Next. Click Next. I'm going to choose the typical and then click on Install. The installation process is very quick for Ignition software. Now click on Finish. At this step, your default web browser will open, and you will be greeted with a Welcome to Ignition. You'll see here different editions of Ignition software. This step is to select which edition and in order to set up the ports and logins for our gateway. This step is called commissioning. So I'm going to click on the Ignition software, the one in the middle. Here where you need to read the agreement, select I have read, and then click Next. Here you need to create a login. So type in a username and a password. Now you need to remember the credentials you typed in this step because you will need them later to access the Gateway interface as well as the designer. Then click Next. The default ports for Ignition software are port 8088 and the HTTPS port is 8043. And finally, the Gateway network port is 8060. So I'm going to leave the default as they are and then click on Finish Setup. Here, I'm going to click on Start Gateway. Once your Ignition installation is complete and the Gateway is launched, your web browser opens the Gateway homepage at localhost 8088. I will give you a tour of the Ignition Gateway page in another video in this chapter. The next step is to download the Designer Launcher, the second part of the Ignition software that I'm going to use in this course. Now, in order to download the Ignition Designer, I'm going to log in here. Click on Login. Now you need to use the username and password that you created in the previous video. Now from the Home tab, if I scroll down a little bit, click on Download Designer Launcher. The Ignition software detects it's a Windows computer, so you can download the Designer Launcher for Windows. You can also download it for other operating systems if needed. So click Download for Windows. Now double-click on the Designer Launcher shortcut and then install the software. So I'm going to select Install for all users, but you can select any of the options that applies to you. Click Yes. So I'm going to click Next, and then Next, and start the installation. And then click Finish. And now once it's complete, you will see this window where you can add a designer for your getaway. Usually, each ignition getaway will have a designer associated with it. So I'm going to click on Add Designer. And here you will see a list of the getaways within your network. So for my computer, I have a local getaway and one with an IP address. This step is to set up the link between the designer file I'm about to start and the getaway web page. Now you can select any of the options depending on your application, but for the introductory projects that I'm doing in this course, I'm going to select the local getaway because both are installed on the same computer. So I'm going to select the local host here and then click on Add Designer. Now in order to see the settings for each designer, I can click on the dots here. And then I have different options: manage, go to the getaway, create a shortcut, export, delete, etc. So if I click on manage, here you can see the designer name, the getaway address, the timeout, etc. I'll leave the default settings as they are, and then I'm going to click cancel. Now, if you want to see the settings for the designer, you go to the settings here. And then here you have different tabs if you want to change the setting for the designer launcher. Again, for the projects I'm doing, I'm going to leave the default settings as they are, and then I'm going to click cancel. You can read more about each setting in here. The designer launcher locates all getaways that are available on a local network. Each designer that is added to my designers list represents a shortcut to a particular getaway. And once that designer is open, you can access or create new projects on that getaway. So the designer launcher is not specific to one getaway. You can use the designer for multiple getaways. In the example you see on the screen, I have 3 designers. Each one is for a specific getaway. Notice that the IP address is different for each. If you need more information about the designer launcher, you can refer to the Ignition website. The getaway webpage is where information is stored, where all of the general configuration happens. For example, setting up your device connections, database connections, OPC configuration setup, and many more. The Ignition Getaway is a web server. You can access Ignition Getaway webpage using any browser. Ignition supports most web browsers like Microsoft Edge, Chrome, Firefox, etc. I'm currently using Microsoft Edge. Now, since we have the software downloaded on our local computer, then we can access the getaway by typing localhost : the port number 8088. Now, if the getaway is installed on a different computer or server, then we will need to know the IP address of that computer. The example you see on the screen, if I want to use the computer on the left-hand side to access Ignition software that is installed on the computer on the right-hand side, then I need to use the IP address of the Ignition software to access it from the getaway. Ignition Getaway homepage consists of 3 sections: Home, Status, and Configure. Now the orange banner in the middle is showing the free trial timer. The trial mode gives you a free 2-hour trial with full functionality of Ignition software, which is a great amount of time when working on demos or projects. When the start period ends, you can reset the trial timer back to the 2 hours. Now it's currently showing it is expired, so you can reset it by clicking on here. And obviously now I need to sign in order to reset. So I'm going to click here. And then when you log in, you need to use the same credentials that you created when setting up the getaway. Once you log into your account, click on Reset Trial. And here you see the timer. It's showing a countdown for the 2 hours. Now in the home section here, you have the options of downloading Launcher Designer, similar to what we did, or downloading Vision Client Launcher. And if you scroll down all the way to the bottom, you'll see links to many resources provided by Inductive Automation if you want to learn more about Ignition software. One of them is Inductive University, where you can have access to their educational videos. Now, if you click on the Status tab, the Status section gives you an overview of the system. It's to see how the Ignition system is actually doing. If there's anything wrong in one of the connections, it would turn red. And then within the Status tab, you can have access to different options: the performance, reports, tags, many options, database, designer, etc. Now the third tab is Configure. The Configure section is where you can add all the settings for all the different parts of the Ignition software. This section for me is where you actually set up what is needed for your SCADA system. Now you can find settings for the system itself, having licensing, the different models, the getaway settings. You have information for the networking, the security, the database, and the different tags in the system. The one I'm going to use in this course is the OPC client, the OPC connection, and OPC quick client. Now there is a search option here. So for example, if you're looking for tags, now it's showing you where are the tags in the Ignition getaway. Here are more information about the Ignition getaway if you want to read more, and the 3 sections: Home, Status, and Configure. Now to open Ignition Designer, double-click on the icon here. Now this window shows you a list of the different designers available. You can either select one, for example this one, and open designer, or you can create a new designer. So for now, I'm going to select this one and click on open designer. This step is actually to tell the designer launcher what getaway I need to create the project in. Here, you need to use the same credentials that you used for Ignition Getaway. And now this window, you will have the option to access all the available projects for this getaway. Currently, it's empty. There is no project yet. So click on New Project here. And then give it a name for that project. One thing that you need to keep in mind that you cannot use space in the name, but you can use an underscore. So what I'm going to do is I'm going to give it a name, Demo 1, for example. And then the project title would be Demo. I'll leave the other settings as default, and I'm going to click on Create New Project. Now this is the Designer User Interface window. This is where the project development actually happens and where you can design your system like creating an HMI. In the middle is where the main development is done. The left and right-hand sides are the windows and panels to facilitate the development of your project. So now I'm going to create a new window. I'm going to give it a name. I'll write demo as well, and then click on create. Now, once you create this window, you can see it on the left-hand side in the project browser over here. So in the project browser, under Vision, you have access to all the different windows within this project. I'm currently having only one window, which is Demo, but for other projects, you might have a couple of windows within the same project. Now, once I create a window, it's showing an empty white page in the middle to start the designing. Now, in order to add items into the window, I can select them from the component palette. In the component palette, you have different sections. You have input, buttons, display, tables, charts, etc. So I'm going to select a couple of them to show you. Once I want to grab this item, you can click on it and drag it into the window. The same thing for any other item. So multi-state button. I can select one of the display, let's say the LED display. I can have some level indicator icon, etc. You can also select items from the symbol factory. So click on this little icon here. And here you have access to multiple icons that you can use to create your HMI. And you can choose either basic or an enhanced icons. And then you'll do the same thing. So for example, I'll drag it to the left a little bit. And if I want this push button, you just select it and drag it into the window. So I'll have a couple of items. And then I'm going to click close. I can also use the drawing tools on the right-hand side here. So I can select, for example, a circle shape, and then I can draw it anywhere in the window. Now the items will not show any data unless I link them to a data source, meaning tags. I can do that using the tag browser on the left-hand side. Now the tag browser shows all the different tags we have in the system. I currently have nothing, so click on the plus sign here and choose Browse Devices. Now in the next demo, I'm going to show you how to add an OPC server to Ignition Getaway and then add the tags here in order to show the data in the designer. So for now, I'm going to click Cancel. Now in this tab over here, you have some editing tools. So for example, if I want to design the HMI in a way that I have two items and I want to send this little icon to the back, I can use one of the icons here. I can also use zoom in, zoom out, or rotate. Now this project in Ignition Designer, you can access that if you want to edit or delete it from Ignition Getaway. So if you go back to Ignition Getaway again and click on Configure, you might need to log in if you're not logged in already. Here under Configure, System, you can click on Projects. And I currently see the same project that I just created in Ignition Designer. So you can edit it if you want to delete it, copy it, rename it, etc. Now that I have finished the setup in Ignition Getaway, I'm going to cover step 2, where I can see the tags in Ignition Designer. So double-click on the Designer Launcher. And now I'm going to choose this designer, the localhost and then click on Open Designer. Now again, in order to log in, you need to use the same credentials that you used for Ignition Getaway. Now, here you have the option of creating a new project, or you can select one that you have created before. So I'm going to click on the project that we worked on in one of the previous videos, and I'll click Open. All right, I'm going to scroll down a little bit and click on this window. So now the first thing I'm going to do is I'm going to delete everything we have previously, select it all, and choose Delete from the keyboard. And then click Yes. Now I have the OPC UA connection already added into the Ignition Getaway. In order to access the tags here, I need to go to the tag browser, click on the plus sign here, and then choose Browse Devices. Now what you see here is the OPC servers that I already configured in the Ignition Getaway. So I currently have Cogent Data Hub and the default one, which is Ignition OPC UA Server. The two options you see here match what you see here in the Ignition Getaway under OPC Connections. So going back to Ignition Designer, now I need to click on this little icon beside Cogent Data Hub in order to expand it. Then for the data sum, I can choose any tag I want to display. So for example, I can choose frequency and then click on this arrow icon in order to add it. Then I'm going to choose the ramp and maybe the sine value. And then click OK. Once you see the tags, you would see them here under the tag browser window, all the tags selected with their values showing in real time. Now the next step is to show the tags into the HMI. So I need to grab items or components from the component palette. So I'll scroll down, try to select something. Maybe I can grab the label. So click on it and drag it into the main window. I can also select maybe another item. So I'll select a text field here. The next step is to link the text field or the label with the tag that I want to show. So for example, for the text field here, once you click on it, I'll drag it to the middle, and you go to the Vision Property Editor. Go under Data, and then for the text field, click on this little icon. This window is for property binding. I want to bind this text field with a tag. So go to the tag here and then click on the tags in order to expand them. And then I'll choose maybe the sine value. And then click OK. So what I did here is to link the tag that I got from the OPC UA with this text field. And this is called a property binding. Now I can do the same thing for the label, for example. If I click on the label and then I go to the data here and I click on the property binding, this little icon beside the pen, and then go to the tag, expand the tags that you have in the system, and then this time I'm going to choose, for example, the ramp and click OK. I'm going to expand the window a little bit so you can see the full value. Now what you see here are values in real time, showing values coming from OPC UA server into Ignition Designer. Now I'm going to grab back the window from Cogent Data Hub. If I click on View Data, then DataSim, and then going back to the designer, you see the value coming from Cogent Data Hub showing in Ignition Designer. So currently I have the values for the RAMP over here and the sine values. All right, so in order to make the HMI look a little bit presentable, I'm going to grab a label here and then drag it beside the value. And then if you go back to the Vision Property Editor, under Data in the text, click on this pin icon. And I'm going to write down a description of this tag. So this one is currently showing the RAMP, and hit Enter. And then I'll grab it closer to the value. I'll do the same thing for the other value. And then again, I'll go to the Vision Property Editor, under Data, Text, to this little pin icon. And this one is showing the sine value. So getting to this point, we have successfully linked the two software. Data are coming from the simulation software to the OPC server, and then we are presenting them in Ignition Designer. Now I want to show you what happens if one of the software is closed or the trial period is over. Alright, so now I'm going to close the window from Cogent Data Hub and the software and go to the right-hand side, right-click on the icon and click Exit. So as soon as I do that, you see that the tags are not showing the data in real time, indicating that the tag value is not available anymore. So if you see this, that means the tag source is not available. So I click on the DataSim again. And as soon as you open Cogent Data Hub software again, you see the data showing in real time in Ignition Designer. Now, on the other hand, if you still see the values of the tags showing in real time, but they are in red, and here it says the trial expired, that means we need to reset the trial timer in Ignition Getaway. So go back to Ignition Getaway. You notice here that the trial is expired. So you need to reset trial. Click on Reset Trial. As soon as you do that, now the values are showing. For this chapter, I'm going to apply everything we learned so far and create a SCADA project. In the example you see on the screen, I have a field application scenario, filling a water tank. The application has two valves, one for filling and one for discharging, and a control panel as well to control the process. Everything is connected to a PLC, and I use a PLC ladder logic programming software to program the process. Then using an OPC server to transfer the data to a SCADA software for monitoring. For that, I'm going to use a factory I/O scene that has the application of filling a water tank. Then using a simulator PLC from Connected Components Workbench software. And using Cogent Data Hub OPC server to connect to Ignition software. What you see here is considered a SCADA project, although I'm using a factory simulation scene, but I'm looking to get the data out of the application. That is very similar to what an actual system is. In a real system, instead of data coming from a simulation factory software, the process data would be coming from real physical devices, sensors, machines, PLCs, controllers, etc. However, the part where I share the data between the software would be very similar. It's just a matter of adding the PLC data into an OPC and then transfer that into the Ignition software. So, as long as we have an OPC server for the specific PLC device we're using, we can access the data from any OPC client. I'll be going through the steps of adding the data coming from Factory I/O scene to the software that I covered in this course: Cogent Data Hub software and Ignition software, ending with a demo in Ignition Designer software. And here is a simplified overview of the main parts for this SCADA project: Factory I/O software, 2 Connected Components Workbench software, then OPC Data Hub, and finally Ignition software. By the components for our SCADA project, we divide them into software and hardware elements. So the software for our project are Connected Components Workbench software for the PLC ladder logic programming. For OPC, we're using Rockwell OPC DA server and Cogent Data Hub. For SCADA Ignition software, using both Ignition Gateway and Designer. And finally, since we're using a simulation software to mimic the factory settings, the Factory I/O software is also part of the software components for our project. For the hardware, it's going to be the computer I'm using. And if we were using real physical devices, then we need to include the sensors, the machines, the controllers, the PLC under the hardware component. But for our case, they are part of the simulation software Factory I/O. This is the basic SCADA architecture. And here's the SCADA architecture for our project, covering the field devices, the controller, and the software used for this project. Now I'm going to show you a demo of the application covering Factory I/O software and Connected Components Workbench software without using the software related to SCADA yet. I have provided you with both the Connected Components Workbench software file and Factory I/O scene file. You can find them in Chapter 4 folder. This project is to fill and empty a water tank with a timer using a scene from Factory I/O software. I used Connected Components Workbench software for the ladder logic program. Connected Components Workbench software has a simulator PLC that you can access by clicking on this icon here. So now the first step is to click on Power On, then download this program into this simulator PLC. Once I download the program into the simulator PLC, then I need to go to Factory I/O software and connect this scene with the simulator PLC. Now I need to run both software. The process begins when I press on the Fill push button. The filling continues for 15 seconds. And once I press on the Discharge push button, this will let the water out of the tank. Check the steps for developing the ladder logic program, understanding the Factory I/O scene, and the input and output tags of this application. I'm not covering the programming steps in this course, as I want to focus on the SCADA application. This chapter is to cover and focus on the steps of transferring data from Factory I/O and Connected Components Workbench software through an OPC to Ignition software in order to visualize the process data. This step is to add the data coming from the PLC into an OPC. the Connected Components Workbench software has a Rockwell OPC DA server that we can access using any compatible OPC clients. For the OPC client, I'm using Cogent Data Hub to receive and display the data. The data in Connected Components Workbench software are to show the application data in Factory I/O scene, mimicking a factory setting. The OPC server for our simulator PLC is Rockwell IXLCIP Getaway OPCDA. Now I have the Connected Components Workbench software open, and I have downloaded the ladder logic program into the simulator PLC. And I have also connected the Factory I/O software scene into this simulator PLC. Now I need to go to Cogent Data Hub, so double-click on the icon, click OK. Then for this icon here on your right-hand side, right-click and choose Cogent Data Hub. Select OPC DA. Now, since we're using the Rockwell OPC DA server, I need to make sure that Cogent Data Hub acts as an OPC client to this server. And now I need to add the Rockwell OPC DA server here, so click on Add. And for the connection name, I'm going to name it Micro 850 Simulator PLC. And for the computer name, I'll leave it as a localhost. Now for the OPC server name, from the drop-down menu, I'm going to select Rockwell IXLCIP Getaway OPCDA. Now for the data domain name, I'm going to give it a name as Connected Components Workbench Software. I'll leave the other settings as default and click on OK. Then click on Apply here, and always make sure that the status is running. Now, in order to see the data coming from this OPC DA server, click on View Data. Then click on the plus sign besides the Connected Components Workbench software, which is the domain name, then Controller, Micro 850, and finally Micro 850. Now all the data under Micro 850 are the data coming from the Connected Components Workbench software. So if I scroll down here, you see the data showing from the controller variables as well as the local variables. The same thing if you click on Directly Represented Variables. Here you would see the inputs and outputs of our simulator PLC. Now, in order to see the data in real time, I need to make sure that the simulator PLC is in the run mode and the Factory I/O scene is running. And now once I activate the application in the Factory I/O software, so I'm going to go ahead and click on the Fill push button, you would see the data change in the OPC client side. So at this point, we have successfully added the data coming from both the Factory I/O software and Connected Components Workbench software into our OPC client, which is Cogent Data Hub. The next step now is to add the OPC server to Ignition software. First, by adding the OPC server into Ignition Getaway. Go to Ignition Getaway by typing localhost:8088 on your browser. Then click on Sign in to reset, and then you need to log in using the credentials you chose in Chapter 3. Click Reset Trial, and then go to the Configure tab and scroll down until you find the OPC connections under OPC Client. Click on Create New OPC Connection, and here you have the option of adding both OPC UA or OPC DA clients. For this project in this chapter, I will demonstrate the connection using OPC UA. Because OPC UA is a widely used industrial standard, and Ignition software in general supports connections to any number of OPC UA servers created by any manufacturer. Since the data coming from Connected Components Workbench software through an OPC DA server, and it gets received in Cogent Data Hub as an OPC DA client. Cogent Data Hub software acts at the same time as an OPC UA server for any OPC UA clients. So, in this case, when using Ignition software, we can see Cogent Data Hub as an OPC UA server and Ignition software as an OPC UA client. So now click on OPC UA and select Next. Now for the endpoint URL, go back to Cogent Data Hub, then choose the first port here and click on Copy Endpoint. So what I'm basically doing is I'm taking the endpoint URL of this OPC UA server and I want to paste that in Ignition Getaway webpage. Click Next. Choose the first one, click Next, and then for this course, for the demo projects, I'm going to choose the first one, and then select Next, click Next, and this is just to confirm the connection settings, and click Finish. Scroll down, and then click on Create a new OPC connection. So we have successfully added the OPC Cogent Data Hub into our Ignition Getaway. And the status here, it's showing connected. So I'm going to zoom out a little bit so you can see the status. It's showing here connected. That means we have successfully added Cogent Data Hub OPC UA server into Ignition Getaway. Now, in order to see the data, so scroll down, go to OPC Quick Client, then click on the plus sign besides Cogent Data Hub, then Connected Components Workbench domain name, controller, Micro 850, and Micro 850. Scroll down. Now, if I want to see the data in real time, click on Run for the Simulator PLC. Then for the Factory I/O scene, select the Run mode and click on the Full Push button. Now, in order to see the data, so scroll down here and choose OPC Quick Client. Then click on the plus sign besides Cogent Data Hub. Then the plus sign besides the domain name, Connected Components Workbench Software. Then controller, Micro 850, and Micro 850. And here you would see all the data coming from the OPC UA server. Now, for example, if I want to see data in real time, so let's say, for example, the integer out 0, I'm going to click on the subscribe. Then I'll scroll down here. It says the quality good, but the value is 0. So go back to the software, make sure that the Simulator PLC is in the run mode, click OK, and that the factory I/O scene is running. So click the run mode here. Now, once I click on the fill push button and the timer starts timing, you will see that reflected in the value in ignition getaway. So now what you see on the screen is that the data in factory I/O software are being transferred into Cogent Data Hub and then finally being presented in ignition getaway from an OPC UA server. Now that I have finished the setup of adding the OPC UA server in ignition getaway, I'm going to cover step 2, that includes adding the tags in Ignition Designer in order to design the HMI for our SCADA project. Double-click on the Designer launcher, then select this designer, localhost, and then choose Open Designer. And here, use the same username and password that you used to log in into Ignition Getaway. Then select a new project. And I'm going to give this project a name and a title. So for the project name, I'm going to name it Filling Water Tank. And for the project title, I'm going to name it SCADA HMI. Then select Create New Project. And now I'm going to create a new window, so I'll give it a name, Water Tank, then click on Create. Now once you create this window, you can access it from the project browser. So I'm going to adjust the window a little bit so you can see. And you would find this window that we have just created under Vision and Windows. Now I want to create an HMI to monitor the process I have in Factory I/O. I want to create something similar to the demonstration you see on your right-hand side. This HMI is to show the process in real time, showing the status for the fill push button and fill valve, the discharge push button and discharge valve, as well as the display time. Now, in order to make the graphic dynamic and display the values in real time, I need to bind or associate each component with the proper tag source. The original tags source is from Factory I/O software. And I have also added them in the Connected Components Workbench software. Here are the addresses for each item I want to display in the HMI. So what I'm going to do first is to go to the tag browser. I'm going to adjust the window a little bit as well. And then under the tag browser, click on the plus sign here and choose Browse Devices. What you see here are the OPC servers I have added and configured in Ignition Getaway. Now click on the Cogent Data Hub here and then choose Connected Components Workbench Software, the domain name, then Controller, choose Micro 850 and Micro 850. And what you see here are the tags from Connected Components Workbench software. And here are the tags I'm interested in adding into this project. So first, click on the Boolean in 0, and then click on this arrow icon. This will add the tag into our project. Then choose Boolean in 1 and add it to the project. Then choose Boolean out 0 and add it to the project. Boolean out 2, integer out 0. And I'm also going to add the time in integer. All right, and click OK. Now you would see them added into the tag browser. I'm going to adjust the window as well so you can see all the tags. Now I have all the tags I need in order to create and design the HMI for our SCADA project.